cooperate. After this brief, I promise it was going to be brief introduction. I again say to all of you, good morning. I really thank you for joining us today in this UTEX Manufacturing Alliance digital event. We are sure it will be very interesting for all of you to have a better understanding of a great topic such as predictive maintenance, how to improve production processes. I invite you all to share with us your questions about this topic. You can write your questions at the chat of this meeting room right now. I mean, later we'll pick up some to ask them to our panelists. Please don't wait until the end of the panel to send your question. You can do it anytime starting now. Today, we are honored with the presence of three great panelists, all of them with huge experience in predictive maintenance and manufacturing. I am sure they will offer us different points of view about today's topic, sharing with us a great vision about it. Please let me introduce you Felix Kraft, CFO of AI-O-Matic Solutions. He has a strong financing background and is an entrepreneur since he founded his first company when he was only 18 years old. Good morning, Felix. Our second panelist is Tom Robautz, who is working as a 4.0 director for iCare. He believes that the power of data in maintenance and production environments to increase performance cannot be underestimated and is widely endorsed at this point in time. As an engineering generalist, Tom likes to look at things in a broad perspective in order to obtain business value for the customer rather than only uptime. Tom has devoted his career entirely to the maintenance organization, production and project planning, process and reliability, engineering, planning and scheduling, plus shutdown management, quality management, Q&A, and quality monitoring of critical spare parts, automation, and data innovation. Since 2017, Tom is reliability consultant and is a certified trainer coach at iCare. With his extensive knowledge, he guides several industrial players in the maintenance planning with FMEA and data innovation projects. Last but not least, please let me introduce you Ricardo Rubin, Industry 4.0 and digital transformation evangelist with more than 450,000 views cross-platform and more than 8,000 people followers on social media. Ricardo is a production engineer with an MSc in business development and marketing that loves to share stories about how technology is shaping the world. So after this brief but impressive introduction, I will shut up and I will let the experts speak. Tom, good morning. First question for you. We hear a lot about Industry 4.0 and its applications in predictive maintenance, but why are these solutions not more widely spread through the industry?
Good morning, Federico, and thank you for the question. I think, well, it's not only my opinion, but we see a lot of stuff moving in the predictive maintenance world, and there's plenty of new companies entering the market. What is clear to me is that the topic is really sexy. Customers are really struggling with the topic and are trying to find solutions. Nonetheless, it's a really technical world where you need a lot of background, where you need a lot of know-how and know-why to be able to implement proper solutions. And I think customers currently are really struggling with that element, finding the good partners, and if they have the good partners, finding the right business cases, which is quite challenging.
Thank you so much, Tom. Felix, what makes, good morning, first of all, what makes predictive maintenance so innovative?
Yes, good morning from my side as well. Good morning, Federico. Thank you as well for the introduction. I think the innovation itself is basically the technology you need for predictive maintenance. So to make it actually work You need to use the state-of-the-art AI methods to actually get the context of the whole machine or the manufacturing hall. And once everything is perfectly set up, like Tom said, yeah, predictive maintenance is actually there to detect failures before they actually occur. And obviously that is, yeah, a huge step towards the next time or the next generation in maintenance and digitalization in the whole world, probably.
I remind all of you guys that you can intervene in any moment. I mean, no need to wait for your own questions. If you want to say anything about some other panelist question or intervene, raise your hand or just speak, and that's it. Okay. Great. Ricardo, good morning. What industries can benefit from predictive maintenance?
Good morning, Federico. Good morning, Felix and Tom and everybody joining us. Yeah, I mean, that's a good question, right? Like, what industry can benefit from predictive maintenance? And the answer is really broad, because I think that many industries in the manufacturing world can actually benefit from this. If you think about it, when you work on continuous processes or batch processes, you have machines that are working on a continuous basis. And each time that there's an unpredictable downtime or there's unplanned downtime, you can lose a lot of money, not only in terms of the production itself, but there's some other costs that are related to, for example, customer satisfaction, or you have a problem then with logistics that is actually tied to the production that didn't come out at the right time and so forth. So there's a lot of, like, I would say, hidden cost behind actually around unplanned downtime that can add on. And, you know, people tend to see it just as, oh no, my machine is not working, I just lose, I don't know, $100,000, 100,000 euros per hour every time it's not working. And the truth is that there's so much more cost related that they're just hidden underneath the surface that can actually add value. So predictive maintenance not only just works for industries to maintain a continuous process, but it also helps them have a better customer satisfaction, have a better relationship with their partners, with their logistics services and so forth. And it's like it's much more complete. Now, as Felix and Tom were saying, it's using the data to actually not only improve your production, but also to improve your customers' satisfaction, improve your partners' relationship, and so forth.
Federico, you're on mute.
Thank you so much, Ricardo. Sorry, and thank you, Tom, for letting me know that I am on mute. Otherwise, I will continue speaking. Well, more questions. Tom, how does predictive maintenance improve the production processes? And to what extent are they interconnected? Now you are on mute.
Now I was on mute. No, as Ricky was mentioning, and I think it's an important point. In the past, maintenance organizations were isolated within the organization, and they had their own budget. And if they wanted to find their business case, they would look for it within their own budget. But we have to think of predictive maintenance in a whole, reliability in a whole. That the goal of each of these departments is to improve output, to improve efficiency of the production department. In the end, it's production making the money, and it's reliability spending them. No, just kidding. But in the end, our goal and our goal of the reliability department is to improve performance in the broad sense of production. So hence any improvement with any technology that we might bring towards production will or should directly be translated in a gain in production, more uptime, more efficiency, better energy efficiency. Those are just some elements which we typically aim for, but that's clearly the gain of the production department, not the gain of the reliability or the maintenance department. Definitely, they will also benefit from this predictive maintenance approach, but that's not the main focus. The main focus is uptime, is production, is efficiency.
So Tom, I just have a follow-up on what you said. You mentioned that it's the production teams that are working, right? When we talk about new technologies, right? For example, so the solution that Felix is offering, how does new technology interact with the production team and, for example, internal IT, or if they have internal legacy, you know, like how does that work with existing infrastructures that are already there?
That's a quite complicated question, but thank you, Ricky, for the question nonetheless. Legacy systems, they're a bit bipolar, I would say. On one end, they can be a pain in the ass because they're not easy to connect, and they're quite challenging to incorporate into new solutions. So sometimes we can merge all the data which is in the legacy system towards a new system, but often we have to look at a tailor-made connection in between them. But on the other side, those databases, those legacy systems, they are a really valuable data source. If I look at the projects that we come across, customers of ours, they contact us for 4.0 solutions whenever there is a case which is really complex. And in those cases, you need to have all the data and all the wisdom accumulated during years and years. You need to have them at your disposal as well. So definitely these systems should not be neglected. They should be used and valorized in your project. But doing so is often a challenge.
Thank you, Tom. Let's continue with one question for Felix. Felix, what distinguishes predictive maintenance from other maintenance approaches?
Yes, I think in general there are three ways of doing maintenance. So the first one is the reactive maintenance. Reactive maintenance means that it's basically too late, so the machine or the part has already failed, and reactive maintenance is associated with high costs and obviously production losses. The second part, on the other hand, is preventive maintenance. Preventive maintenance is based on experience, mainly human experience. And the disadvantages of this is that components are replaced, which are actually working still very, very smooth. And so that is basically a waste of resources. And then we have the third one, which is our topic, predictive maintenance, which is basically right in the middle and trying to find the sweet spot between preventive and reactive maintenance. And it's trying to predict once a component is going to fail, and so that the engineer or the worker can replace the part just before it breaks, so that we don't waste any resources or too much resources in that case. And predictive maintenance leads basically to just-in-time maintenance in the future, or will lead.
Thank you, Felix. Question.
Sorry, I just have a follow-up for Felix.
Sure.
So Felix, just to get a better understanding, I mean, I understand the three different types of maintenance. Which one, let's say, is, I mean, because you're not going to use predictive models for every asset. Maybe some assets are not even worth it, right? So like, how do you choose which one are more suitable for each asset, let's say?
Yes, exactly. That is definitely correct. So our aim is to build a product for predictive maintenance, and we are on a good way to do that. But obviously, we will need some human experts or experience within that, because obviously, like you are saying, some of the engineers or workers know best which parts are going to fail. So obviously you have big machinery where some parts are not going to fail for the next 20 years. So you don't need to put 20,000 euro sensors on some parts which are definitely not going to fail. Or on the other hand, you have smaller machinery, which is maybe not that expensive once it's on a breakdown. So same thing, you don't need to put for thousands and thousands of euros some sensors somewhere. So that is what we do together with the engineers or the workers, and trying to find the hard spots for the company, the expensive spots for the company, which are really hurting. And then we build our use cases, or we adapt our product on different parts. So we have, for example, we are specialized on bearings, which are quite critical as well in production, and motors in general. And I think if you do bearings and motors, quite a big part of parts which are critical are covered by our solutions.
Ricky, if I can add to as an answer from my part to your question, because the question is actually as old as predictive maintenance exists. So ever since the 60s, 70s, when RCM was not invented but discovered, let's say, we were struggling with how to invest the limited resources that we have, time, budget, spare parts allocation, and so on. And the answer has always been, and is still today, criticality. What happens if this equipment fails? If this equipment fails, what is the cost of the downtime? What is the impact to the environment? What is the impact to the customers? And so on and so on. So each of these elements will contribute to the criticality of your equipment. And then it's easy. Once that is quantified, the higher the criticality, the more resources you have to invest in it. And I'm talking pre-2000 now, when AI was not really that active in predictive maintenance. But predictive maintenance on its own is quite an expensive maintenance strategy. You have to go to the equipment, you have to measure something, you have to do something with data. So there are plenty of maintenance strategies which are way cheaper. Run to failure, just let it fail and replace it whenever it occurs. That's the cheapest maintenance strategy that is in existence. The only side note is you can only apply it on equipment which is low critical. You will not do that on something impacting the environment. So from that point of view, predictive maintenance, yes, it's more expensive, but the gains are way higher. By applying predictive maintenance, you will lower all the operational costs, and thus your business case becomes quite positive. So it's always a matter of criticality and resource allocation, from my point of view.
Yeah, definitely. So just to add on that, because I mean, at Wizata we work mainly in the raw material industry, so they work on continuous processes. So obviously for them, predictive maintenance is a big priority when we're talking about rotary kilns, vertical kilns, blast furnaces, electric arc furnaces, that they work just continuously, right? And obviously we look for sure, we look at bearings, motors, like the simple things first, but then afterwards you go a bit more deep into the process and try to understand what's going on, and then how actually that affects the quality and how that affects actually your overall process until the end, right? So it's important. I mean, I understand that it can be expensive, that you need to have everything set up, but more and more today, machine providers are already integrating sensors inside of their assets. So if we're talking about big assets, obviously you change them maybe every 30 years, depending on the asset, let's say, a big machine like a blast furnace or something like that. But they already come integrated with different sensors. And then you can connect that to some data infrastructure to clean the data. You create a digital twin, you kind of understand where the data is coming from and how it's contextualized inside of the process. And then from there, you can start creating maybe some anomaly detection and then eventually some predictive maintenance, right? But I'm just trying to answer a question from the audience and I'll share it with everybody. Maybe it makes sense. So it's about predictive maintenance. There's data sharing that happens in the cloud. Isn't this secure? Can we have on-premise software that does the same? And I think, I mean, I can talk about that, but maybe Felix knows a bit more on that subject.
Yeah, I was going to tell you guys that you can see, I mean, we no need to wait until the end of the panel to answer those questions. Since you see those questions, you can anytime answer or speak about them. So which one of the questions that you're speaking about, Natalie's question?
No, the second one.
Okay. Chaitanya, right? Bulusu. Okay. Any one of you guys want to answer, or let me read the questions for those people that didn't read it. Data management is always a huge challenge for organizations as far as preventive maintenance is concerned. The asset data and information aren't likely to be accessed by outside the gatherings. But with predictive maintenance, there is data sharing that happens on cloud. Isn't the security a challenge? Can we have on-premise software that does the same? This is the question. Any one of you want to answer or say something about that?
Yes, I can do that. At Iomatic, we offer a cloud and an on-premise solution to basically cover all the customer wishes. Of course, for us, the cloud solution is easier, especially maintaining our software, doing updates, etc. Because once it's an on-premise solution, we have to work with the IT infrastructure of the company, which makes it obviously sometimes quite complicated and quite slow. So, for example, if there are some problems occurring, it's not our fault and we can't do anything. That's obviously so the risk of the software failing basically switches a little bit towards the customer. So if it's running in the cloud, it's our problem. And if it's a security issue, I wouldn't say so, because basically all big companies like Volkswagen or BMW or whatever are using AWS or AWS cloud or Microsoft Azure cloud and doing everything within the cloud. So I think there is no big difference if you put some more data into the cloud. So we at Iomatic work with Azure cloud, and lots of companies use Azure, and then I think it's not a big security problem. And once we send the data from the company or from the manufacturing side towards the cloud, they are always secured by various codes. So it's not very dangerous to send them through the internet. And once we have the data, we decode them and use it. Of course, if we put a lot of effort into it, we can get some clues of the production process, but that's basically not our aim. So we are not working on that. We are there for analyzing the data, and there are different ways. So, for example, if you stand in front of the manufacturing and you see more and more people coming in, obviously you could say, oh, they are obviously producing at a higher pace. And so basically that is the same, but I wouldn't say it's a security issue if it's in the cloud.
Felix, something I observe in customer context, I don't know if it's supported by your experience, but the question on cloud versus on-premise is mostly asked by those concerned about privacy. What I observe is that the customers who are concerned about data privacy, security, and so on, in the end, they all choose for a cloud solution. So it might sound strange, but cloud is considered as the most safe, the most secure, because it's not live, but near live security patches are updated. If anything happens in the infrastructure, it's rolled down quite rapidly. So in the end, it might sound strange, but nonetheless, it's relevant, I would say.
It's exactly what we say, because if you read in the newspapers that and that company was attacked by hackers, it's just the company cloud which was attacked and not the Microsoft Azure cloud or the AWS cloud. So it's just their own company cloud, because obviously it's not that secure, because they don't have thousands and thousands of engineers working on the cloud other than Microsoft or Amazon or Google.
Yeah. I would probably add that there's also another option that's combining an edge device with cloud. So, for example, we have some clients that are running closed loop AIs on industrial processes. So in order to maintain, sometimes you have connectivity issues because the plants are very remote and there's not good connectivity to the cloud. So you have an edge device that's running all the data in real time. And then when it connects, it sends the information back to the cloud. And then the cloud is kind of like a user interface where you can actually access the data and then manipulate it and play with it and so forth. But I agree with Felix and Tom. I mean, we work with Microsoft and AWS as well, and normally all of our clients work on those clouds, and we're not taking their data out of that cloud. We're just connecting to their infrastructure and then using the tools that they already have in house. So it's not like a disruption of the workflow. It's actually like aggregating to what they already have.
Thank you guys for this great discussion, interaction. I remind all our audience that please don't raise your hand to speak, just write the questions in the public chat, okay? Only the speakers, only the panelists can speak. The audience can write the questions in the public chat and we will speak about those questions. And about questions, one question for Ricardo. Ricardo, what's the most efficient maintenance programs? Predictive, reactive, preventive, etc. Which one is the most efficient?
Yeah, so I think Felix actually touched on that a bit when he explained the 3 different types of maintenance. For me, it depends on each customer and each asset, right? Depending on what they want to do, what they want to achieve, and what they're looking to improve as the input, they can choose either of the 3 things. Like, for example, you have a car, you use reactive and prescriptive maintenance, right? Like after X amount of kilometers, there's a light that pops up and says, hey, you have to go to the mechanic because you need to change the oil or whatever, right? And that's more prescriptive. You're not going to use predictive maintenance on a car because if it burns down, you just get out and that's it, right? But if you're talking about a vertical kiln that processes tons of raw material constantly every day, then you want to know when it stops, because one downtime can cost up to 200,000 euros or more, depending on the industry. And then that can also obviously have a huge impact in further supply chain problems. So depend again on the industry and what type of manufacturing you're doing. But I think that what's important is to understand which options are available and then try to assess, as Tom explained, right? Lost the word.
Criticality.
Yeah, criticality. Thank you. Like based on the criticality, choose which one works best for you.
Thank you, Ricardo. More questions. This one for Tom. Tom, can AI and 4.0 technologies be delivered off the shelf to customers?
Definitely there is off-the-shelf solutions, but off-the-shelf solutions actually answer generic problems, I would say. What we see our customers are struggling with are not necessarily these off-the-shelf problems. So 80% of the projects that we deliver are tailor-made, where we look with the customer into defining what is exactly their problem and how can AI or 4.0 technologies, how can they solve that problem. It's not the solution or the technology that is driving the innovation and is driving the project. It's really the need from the customer that should be put centrally. So my answer would be no. By default, it cannot be delivered. There are exceptions, but you always have to adopt and apply the know-how which is available at the customer, which is available at the supplier, and turn it out into the best solution for you, for the customer.
Thank you, Tom. One more question for Felix. Felix, what advantages can be achieved through predictive maintenance?
Yes, I think the biggest advantage is obviously, like we said before, it's cost effectiveness, because downtimes can be reduced massively, and therefore maintenance costs can be lowered. And in addition to lowering everything and to collecting the data, you will increase your productivity probably on the other hand as well. So that is the main advantage, but the main advantage is obviously cost effectiveness.
Maybe to give some practical example, Felix, during the last 3 proof of concepts that we were running at our department, The complete investment was actually returned by the incident that was detected during the proof of concept only, which is something taking typically a couple of weeks, maybe a couple of months, depending on the size of the proof of concept. But imagine that the complete investment is already returned during that short amount of time. That gives you an insight, Federico, on the potential of this technology. The potential is huge if you identify your business case right.
Yeah, I would add that to what Tom was saying about creating like bespoke models for each processes. I mean, there's two type of approaches, right? Like, for example, Felix can talk about specific predictive maintenance for bearings or motors that you can find in multiple assets. So that's a very specific, more niche approach. But then also having a more overall view of the process itself and of the asset can also help. And you have to understand that these industrial manufacturers, their intellectual property is their process know-how, right? So they don't want to share that with the world, because if they figure out a way how to lower cost and keep the quality output at the same level, then they're going to want to replicate it in all of their other factories, but they're not going to want their competitors to do the same, because it's like their process knowledge, right? We're talking about, we're working with process engineers, with operators that's been on the field for 20, 30 years, and we're trying to digitalize their know-how of the process so we can transform it into like a model, right? So once that's done, and that's why it's like very, let's say, personalized, right? You can then replicate internally, but it's very unlikely that they're going to be open to share it. And then you have like the two approaches when there's like more big companies. I mean, talking about Siemens or big players like that they just come and they grab the information, they build a standardized model, and then they resell it based on what they did with the client, right? So that's kind of like the approach today in the market. You have like the big players that are just gonna, do something standardized, and it works because I've been doing it with Shell or whatever, because they have their machines, they have the process, so it's all interconnected, so it's easier in that way for them. Or you have the other approach where you need to take time, but you work closely with the partner, you work closely with their operators and engineers, and then you build something from scratch, but it's specific for that industry and for that process, that then you can scale up. And at the end, in the long term, it's going to be more beneficial.
Thank you, guys. Ricardo, one question for you. How companies can be sure that they run a successful PDM program?
Okay, so that's a complicated one, right? I think what Tom was saying, that choosing the right business challenge is very important. Like, you have to understand what you're addressing, right? What you want to achieve. That has to be the most important thing, that you have that clear. Then based on that, you kind of have to reverse engineer a little bit and understand, okay, what do I need to get there, right? Are you measuring the right information? Are you gathering the right data? How do you access that data? Because there's a lot of groundwork that has to be done before you can start building the model in order to actually be benefiting from the solution, right? So, for example, Tom, I don't know how's your experience, maybe you can add on that after, but if you want to do a proof of concept, like, it's not the same to do a proof of concept with a client that's already has their data in a data warehouse, and they're kind of already playing with their data. They're already, up and ready and connected. That's a complete different project than if you start with somebody that doesn't even have sensors, right? So, like, how do you approach those? And then how you as a provider can differentiate yourself from, okay, I provide hardware or I provide software. Like, where am I going to actually add value to you, right? So it's important from both sides, right? From the provider side, that you understand where you are and what the value that you can give specifically to the client. And then the client also needs to understand where they are, at what stage during the transformation journey they are, let's say. And then once all of that's ready, having a clear goal of like, okay, look, I'm having problem with asset availability. I want to push it up to 95%, for example, because right now it's at 80. I mean, that's a bit overreacting, but just giving an example, right? So they have a clear goal, and then you have the asset, and then you have all the information, and then you can start building the project specifically for predictive maintenance. But That's really rare, let's say. Like mainly people or customers come and they're in different stages, so you kind of have to like walk them through. That's at least from our experience. Maybe Felix or Tom can add a bit of that.
I definitely connect with what you're saying, Ricky. It depends a lot on who is the customer, what's the maturity of the customer. A plant manager contacting us with a business challenge is a complete different project than a maintenance manager contacting us regarding his bad actor in the field. So definitely those are two different dimensions. On the other hand, you've got the maturity of the customer. As Ricky is referring to already, if they've got all the data nicely managed in the data warehouse, often it's an advantage because the data is accessible, but often it's a disadvantage as well because all the data is already being processed and manipulated, and in doing so, the value of the data might disappear. Yeah, to answer this question, it's always on a case-by-case approach. No two customers are the same, even though they have got the same architecture or platform. No two customers are the same. It's always implemented differently, and the maturity is always different. So even though I would like to have a generic approach, one size fits all, it never applies.
And I would just add a really quick trust. So obviously, if you start a predictive maintenance project, it's really important that the partners trust each other, because obviously there will be questions from the provider to the customer. And once the customer is not answering any questions, the project will not be successful, and the other way around as well. So I think trust, but that is not just predictive maintenance project. Basically, it's all project in the whole world. But I think especially in predictive maintenance, in our experience, trust is really, really important.
And talking about trust and about new emerging technologies, I want to point out that predictive maintenance is not at all new. We've been doing, I think, the first measurement in eye care that has been performed, or that we're still managing, dates from the late 80s. So that technology, when we pushed it to the European market, it's old. There's only an additional layer of data analytics, which is new, and which has a huge advantage. But in the end, the basics, the acquisition of the data, the interpretation, the expertise that is acquired. Well, eye care is now celebrating its 18th birthday, but it's older than eye care. So we have to put it into context. We're only using innovative techniques, which also date back to the 60s and before. So we're not really handling new technologies. We're just at a crossroad where new innovation has been realized by combining the elements which are there on the table. But Ricky, you wanted to...
Yeah, no, just I mean, I think it's also very important to understand that you need to have, like, if you want to do predictive maintenance on a specific asset, you need to have enough historic data and an incident when that happened to actually figure out why that happened, right? It's not like magic that you have the data and then you're good to go and then you start building the model. You need to actually understand and have that, for example, 6 up to 1 month, depending on the project and depending on the asset. Like if you have 1 year of historic data, and then during that year you had 2-3 downtimes, and then you have the input of the process engineers that they can tell you, okay, what happened on that specific issue and why did that happen. That's what's going to give you the first big leg into actually building your model, right? But it can be something so simple. I mean, for us it's difficult to understand because we're not in the industry, but you go to clients and they have operators that they're on the field, and then one day they enter and they're hearing something and they're like, something's wrong. Like, how do you replicate that digitally, right? Like they're literally just hearing something or seeing something. The machines and the SCADA systems, everything says that everything's working okay, but they are hearing something that's wrong. So like they need to address that, and they by experience they can change whatever measurement or whatever data set that they want to do, because they already know what that means. But then, like, that's the difficulty of where we're working at. Like, how can you actually translate what they see, what they hear, their experience into something that is like binary, that you can actually then create a model for automated response to that problem. And that's kind of where data comes in, and where we're actually leveraging new technologies like computer vision or vibration or audio systems and so forth. But that's like another level of predictive maintenance that comes once you already are very advanced, let's say.
And in the end, Ricky, we know that the operator is right.
Yeah, exactly.
Each time
We
they
don't know
say
why.
something is wrong, something definitely is wrong.
Yeah.
Only the instruments are there to objectify, to quantify, and to give an additional layer of expertise. And that's also the way iCare approaches the use of AI. In fact, internally, we would like to call it augmented intelligence instead of artificial intelligence, because we believe in the power of combining the human expertise with the power of the calculation power and the power of the analytical models. But never throw away the knowledge which is in the field and the knowledge which is available at your supplier's site. It would be a huge loss if you do so. I see that that Pavel also has raised the question. If I can, Federico.
Yeah, sure, please.
Because Pavel is asking, where do we implement predictive maintenance in different factories, different equipments, and so on. To answer that part of the question, that's the default mode at iCare. At iCare, we look at the customer production site. So we will always observe the production process and apply predictive maintenance solutions there. The key is that each equipment speaks in different languages, I would say. And there's equipment speaking in vibration language, equipment speaking in ultrasound language. There's also thermography. There's electrical signals, and so on and so on. So those are the different technologies that we can use. Those are the different sensor values that we can use to monitor those equipments. But in the end, we deploy it on one site, on two sites, on the complete corporate structure. And that's also a challenge that we get from our more advanced customer base, is that they don't want to monitor one asset. They don't want to monitor one site, but they want to monitor the complete corporate level. And they want to leverage the knowledge that they have accumulated. So definitely that is taking it to next level, which is a default level that we approach in iCare. Regarding your question on which parameters do you measure, I think 80% of the technology used is vibration measurement. But within vibration measurement, there's a huge difference between the different sensors that you use and the different acquisitions that you use. So there, iCare is quite conservative. We use the most expensive sensors, and there's a reason why we do so, because they provide the highest quality data. Definitely, our R&D department is looking into new sensors, and whenever that quality rises, we will adopt those as well. But within that vibration spectrum that we're reading, so the raw waveform, there is a possibility to extract features, to extract parameters, and we also use that. But never ever throw away your raw signal. You want to have the raw signal to really go in depth and to provide the added value in the analysis performed. Plenty of suppliers will provide you an RMS value, which is just statistics applied, and it's the average, but then taken to the next level, I would say. But by reducing the complexity of your signal, you will highly reduce the capabilities that you have to do something with that data. So that's definitely a general advice that I would like to give to you there, is make sure that the raw data is available and that you can use it to your advantage. And then to answer your last question, it's quite a short question, but a lot is packed into it. Which algorithms do you use? the ones that work, I would say. And at iCare, we like to keep things simple. So the number of times that we have applied a neural network is way fewer than when we apply just plain statistics. And we just try to increase the complexity of the solution whenever the complexity of the problem requires it. So that way, well, all that you mentioned will be used whenever needed, but only use it when needed. And deploying a neural network will be way more expensive than deploying statistics. So if statistic works, use it.
Great. Thank you so much. We still have a few minutes to go. One question for you, Tom. I think we have been speaking about that, but how does predictive maintenance improve the production processes? So to what extent are they interconnected?
I think we have answered that one already, Federico.
This already? Okay.
Yeah.
Sorry.
Federico, there's one from Andy Russell. The first question actually seems interesting. Maybe you can read it out.
Okay. From Andy, do you see there being a push for new green AI solutions across key sectors, usually part of a green circular economy strategy within a PPM focus? As we see companies trying to get to net zero, could this play a huge role? Anyone? Of you guys?
Yeah. I think obviously predictive maintenance can play a huge role. I wouldn't put the green AI solution label on predictive maintenance as it's just too old, like Tom said before. It's not a new invention, but obviously saving resources is one of the parts to get to net zero. Obviously, and I think predictive maintenance is a huge part of that. But I wouldn't be confident going out there and saying, hey, I'm selling a green AI solution, which is called predictive maintenance. I think the engineers hearing that would not be happy because they are doing it since 40 years. But predictive maintenance is a huge part to get to net zero.
Yeah, one of the advantages of applying, one of the advantages of applying predictive maintenance and AI solutions that actually have side benefits that you didn't before, that actually helping you be sustainable by reducing the consumption of energy, for example. If you can regulate it, or the output of your quality at a specific level of consumption, for example, for your asset, if you maintain it always under this specific threshold, you know that you're gonna waste less energy. And if you can actually have the same quality, then that's a win for you. So there's that part of reducing energy consumption. Like, for example, at Wizata, we're doing an energy reduction algorithm for annealing furnaces in the stainless steel industry. And it's that, you grab the set points and then you kind of say, okay, I want to maintain the same quality, but how can you actually reduce the energy consumption of the gas flow, for example, or the electricity, or whatever it is, right? And then, of course, that also plays into a part of you're producing less waste because your quality is better. So you have to process the same stuff, and then eventually you also get some CO2 emission. That's like a side benefit. Again, it's not, as Felix said, it's not like you're going to sell it as, oh, your green AI predictive maintenance to reduce CO2. No, but in side benefit, you will be able to reduce some CO2 or some energy. So at the end of the day, it's something that you should be able to do and connect it to your sustainability strategy.
Great, guys. I can see Natalie also made a question related to the green field, let's say predictive maintenance as a green field best practices. Do you have any answer for that, or? She said, could speakers reflect on setting up system processes for predictive maintenance as a green field best practices, or not? Maybe not.
Yeah, no. For example, we have a client that produces cement, and we did some predicted models for their assets because they wanted to have more asset availability. So we needed to push the asset availability up to 93%. And we did that, But then a side effect, as I was saying earlier before, was that they managed to reduce the carbon footprint for 3% because the acid was working at a more efficient level than it was before, and then maintain the same quality. So again, it's not the go-to for green field methodology, as I say, as Felix said, but it is a side benefit that you can encounter while you're because at the end, this is going to allow you to understand better your process and to improve your process. And then if you improve your process, then you're going to have gains around the ecosystem, around everything that you're using, right? Like less energy consumption, producing less waste, having higher quality or more constant efficiency. So all of this adds up to what you can improve. And when we're talking about industrial manufacturers that work at 24/7, like 1% benefit is a huge, because you can multiply that per every day, per year, etc., and that's a huge win. So it's a good step forward into, and that's something you can start doing today. You don't have to change your workflow. You can start doing that today to start being more sustainable, let's say.
Well, yeah, please.
Critical, if I can add, because
Sure.
and I think Natalie is referring to industries coming back to the EU, starting with a new production plant and so on. I think there we didn't focus on it, but iCare has a methodology to draft a maintenance plan, let's say, with all kinds of periodic maintenance, predictive maintenance, and so on, related to the design of the equipment. And of the process. So that is one. Definitely, there's a methodology to orient you already in the right direction. Secondly, the cost of data processing and storage and cost of AI, I would say, definitely there is a cost. Applying AI on equipment to follow up that equipment has a cost. So that's generally why you only apply those on the equipment that need to carry the cost. In the end, you have to look at the business case that you're trying to improve. So only apply the technologies where it's relevant and start with a good basis. If you start building on loose foundations, it's definitely not an advice I will give you. So make sure you've got sound foundations and start building on top of that. And it might be that AI is the solution that you need for a certain equipment, but don't forget that there's plenty of other technologies that you should not forget.
Thank you, guys. And I have to say, time is flying, and that was the last question in this very interesting digital event today. Thank you all for joining us today. We hope that all of you enjoyed it. Of course, I did it. Special thanks, of course, to our three great panelists, Ricardo, Felix, Tom. Really amazing sharing the panel today with you all. Now, my colleague Benedict Grutz should give you a present, a little present in the name of the UTech, but he, again, cannot be here today, so I will do it myself. And let me put it here, and I will share my screen again, because as you may know, at the UTech, please, guys, let me know if you can see my screen. At the UTech, we are one of our main concerns and main goals is sustainability, and that's why we are always providing a tree certificate to all our panelists, to all our speakers. That means we are planting one tree for each one of you. This one is for Tom Rombouts, this one is for Ricardo Rubin, and this one is for Felix Kraft. So we are planting a tree in Africa for each one of you in order to reduce CO2 emissions, in order to, let's say, develop or support the sustainability, let's say, in the world. And this is our small gift to three of you guys, the speakers of today, for being here today, for sharing with us your knowledge and your experience, and for being so kind to cooperate with EUTech. So thank you guys again. Later I will send this tree certificate by email, so you can have it, you can share it in social media, you can make whatever you want with it. And again, to our audience, thank you again for joining us today. Please join us at our LinkedIn Sustainable Manufacturing group. Join the UTech. If you find that the UTech can help you guys, and then we hope to see you soon at our next events. And as always, remember, technology obliges. Thank you so much, and goodbye.
Thank you, Felix, for hosting.
Thank you, guys. Thank you.
Thank you very much. And
Thank you, everybody.
Thanks for the tree. Thanks.
Thanks. I will send you the trees. I will send you the trees during the day. Okay.
Yes. Thanks. It's a great idea.
That's good. Yeah.
Bye.
Have a good week, everybody. Ciao, ciao.
You too. Bye.
See you later. And if anybody of the participants wants to continue the discussions in LinkedIn, feel free to contact us, and then let's discuss over there. Thank you.
Definitely. Ciao, ciao.